Welcome to the final webinar on effective maths teaching with a focus on data. My name is Tracy Hughes-Butters and I'll be facilitating this webinar, which has been designed to consider students' errors in the PAT Maths assessment, focusing this time on data and what we as teachers can do to support our students to ensure they are able to demonstrate their mathematical skills and knowledge competently and confidently in unfamiliar situations. Now, from the PAT Maths data, 5 areas of concern have been highlighted for our students in Catholic schools across Australia. So please note that they are not in any order. This webinar will focus on the final dot point, data representation and interpretation. Now, there are 5 examination style questions that we will unpack. Each question targets a different area or stage level. Here is the learning intention and the success criteria for the webinar. Please pause and read. Now, we need to note that we cannot effectively cover everything in a half-hour webinar, so we will draw from the PAT Maths data and analyse a series of sample questions that are similar to the questions that had the lowest achievement rate nationally. The sample questions will vary from years 1 to 6. I will lead your team through a set of focus questions and there will be plenty of time for discussion and reflection. Now, there are 4 focus questions to prompt discussion and reflection with your team. Focus question 1 is to ensure that we, the teachers, understand the key concepts and skills that the question is assessing. Focus question 2 will consider the prerequisite knowledge and skills that our students must have to attempt the question. Focus question 3 will consider why our students have decided on an incorrect answer due to common errors or misconceptions, and we will apply Newman's analysis where appropriate. And finally, focus question 4. What can we ensure our students experience in their learning so that they are able to experience success in this style of question? Now, if you have not heard of Newman's error analysis, here is a quick summary. The analysis breaks down the 5 steps involved in solving a mathematical word problem. Reading and decoding, where the student reads the problem and decodes the words and symbols. Comprehending, the student makes sense of what they have read. Transforming, the student mathematizes the problem. That is, they work out what mathematics needs to be applied. Processing, demonstrating what to do to get the answer. And then finally, encoding, recording the final result appropriately. Now, before we begin our analysis, let's explore a process for reading data representations based on the work of Francis Corcho. Friel, Corcho and Bright state that students develop graph sense gradually as a result of creating graphs and using already designed graphs in a variety of problem contexts that require making sense of the data. So when interpreting graphs, it is crucial that your students have ample opportunity to explain and justify their reasoning and receive feedback from their peers. So provide students with an organiser to guide them as they read and interpret a data representation. And this could be as simple as using the steps that I am about to present. Following this 4-step process to unpack and analyse data representations provides students with a very effective approach to data comprehension. Step 1 is previewing the graph. This initial step may clarify understanding of the basic elements of the graph. Promote discussion with your students by posing questions to clarify understanding, such as identifying the type of graph used. What does the title tell us about the information in the graph? What information is provided in the label on the axis? What are the units in the scale? What is the range of values? By what increment does the scale increase? Is there a legend or key? What does the symbol represent? The second step is reading the data. It's the literal step. Students state the facts directly from the graph using the labels and the scale on the axis to read or locate specific information. Reading between the data. Here, the students are encouraged to look at and make comparisons and observe relationships in the data and to discuss with their peers. Now, the teacher should pose what-if statements for the students to investigate. Finally, reading beyond the data. It's the step where making inferences and drawing conclusions occurs. Encourage your students to synthesize the information in the graph. The teacher should pose questions to identify trends, make predictions, extend the data, and draw inferences. Now, you would have noticed that the first two steps are at quite a low level skill base, whereas the last two steps involve higher order thinking. But all four steps are essential in achieving an understanding of the data. And at some stage, the teacher and students should collaboratively identify the strategies for reading graphs. Add these strategies to the classroom maths wall and to students' journals as a reference. Pause the video and discuss the steps. Welcome back, and let's begin with an example of a question targeting Stage 1, Year 1, focusing on reading a picture graph where the symbol represents 1 unit. Note that only 39% of the candidature was successful in attempting a similar question. Carefully read the sample question, pause the video to consider and discuss the focus questions. Ensure that someone is scribing, and when you're finished, recommence the video. Well, welcome back. Now, the key concepts and skills that this question targets is counting collections and interpreting picture graphs. The prereq skills and knowledge include one-to-one correspondence and collecting and organising the data. So let's consider each distractor in this question and apply Newman's analysis. 4. Well, a reading or a comprehension error. Students may have misinterpreted the question and selected the raspberry category as it is the first in the graph, or they may have counted the number of categories. 5. Another comprehension error. Students may have misinterpreted the question and selected the largest category. 16, of course, is the correct answer. 17, a counting error. Pause the video and discuss. So, what must occur in our students' learning experiences? Well, let's analyse the question to consider the learning needs using the 4 steps. Where does this question fit on the 4 steps? Well, I would suggest that students would be reading the data and reading between the data. Students need to preview the graph to identify and clarify the elements of the graph. They would then read the data and apply this information to answer the question. Now, a focus on accuracy and precision is also important learning. Many students make mistakes simply due to poor counting techniques. So discuss strategies to ensure accuracy, such as writing the subtotal as each category is counted. Pause and discuss. Now, a picture graph is quite like a parts whole diagram, and students need to understand that the parts are like the frequency of each category, and the whole is the sum of all the parts. Now, an effective way to pictorially demonstrate this is to bring each subtotal out and create a line of objects, which is the whole. Pause the video and discuss. The second sample question targets Year 2, Stage 1. It focuses on reading the data from a simple column graph. Note that only 49% of the candidature were successful in attempting a similar question. Carefully read the sample question, pause the video to consider and discuss the focus questions, ensure that someone is scribing, and when you're finished, recommence the video. Well, welcome back. The key concepts and skills that this question targets is reading and interpreting the data from a column graph. It is a low skill-based question. The prerequisite skills and knowledge include reading and interpreting column graphs. Well, let's consider each distractor in this question. Monday. It's a reading or comprehension error. Students may have chosen just the first day listed. Tuesday is a comprehending or transforming error. Students may have chosen a day that is colder than the days nearby in the graph. Wednesday is a comprehending error. They do not understand the task, so they've just guessed. Thursday, a reading or comprehending error, selected the warmest day rather than the coldest. And Friday, of course, is the correct answer. Pause the video and discuss. Well, welcome back. So, what learning experiences will best provide our students with the skills to transfer their knowledge and understanding? Well, let's first identify this question using the 4 steps. I would suggest that students would be working at the step reading between the data. They would firstly preview the graph to understand and clarify the elements, and then read the data for each day. Students must understand what the question is asking. As a group, discuss strategies such as reading the question and then rewording it, such as the coldest day was. It is imperative that there is a focus on accuracy and precision. To answer this question, students will need to make comparisons of the temperature for each day. The use of a rectangular piece of acetate is an effective tool for some students to compare the data values visually. Extend your students by posing more comparison questions such as, which day had the greatest temperature? How did the temperature change from Thursday to Friday? With a partner, discuss what time of the year this week would occur and why did you decide on this time of the year? For all these questions, the power of the learning is the sharing and discussion of student responses in a safe environment. Here is an example of a question targeting Year 4, Stage 2, determining a sector graph that shows the given amounts. Now, only 50% of the candidature were successful in attempting a similar question. Carefully read the sample question. Pause the video to consider and discuss the focus questions, and when you're finished, recommence the video. Well, the key concepts and skills that this question includes understanding sector graphs and interpreting raw data represented as a sector graph. The prerequisite skills and knowledge is the collection and organisation of data. Graph 1 may have divided the sector graph to represent the 4 categories. So there are 4 colours, so we divide the graph into 4 equal parts, rather than the value of each category. Graph 2 may have allocated one segment of the sector graph to each of the 4 categories, rather than each of the 12 symbols. Graph 3, students may have observed the proportions, but were inaccurate with their counting. Graph 4, students had little understanding of representing categories in graphical form, and Graph 5, of course, is the correct answer. Pause the video and discuss. So, what is necessary in the learning? Well, we need to consider whether our students can represent data with a sector graph. Consider a data set and discuss the different categories. In this example, by colour. Students then represent the data using coloured beads, which match the categories, threaded onto a string. Now, this concrete representation presents a parts whole format. Ask questions about the representation, such as, what do you notice about the whole? What do you notice about the blue part, the green part? And what do you wonder? Practice this with a variety of data to build deeper understanding of the parts whole format and the connections to sector graphs. Now, exploring this further, do our students have a deep understanding about the sectors of the graph? Can they match the data values with the respective sectors in a graph? Well, this could be investigated and discussed by taking the line of beads and then forming a circle on a mini whiteboard or on paper. Students can then mark out the circle and then add the sectors and gradations. Discuss the importance of equal gradation so that the data is represented correctly. Remove the beads and label the sectors. Finally, add a title and discuss why it is such an important feature of any graph. Pause the video and discuss. A powerful learning experience is to then present the multiple choice question and discuss the distractors with the students. Ask students to think, pair, share about each possible distractor and decide why someone may choose it. Clarify any misunderstandings. This is necessary to ensure that possible misconceptions are not clouding student understanding. Here's an example of a question targeting Year 5, Stage 3. Selecting the best description for the data in a scatter plot. Only 45% of the candidature were successful in attempting a similar question. So carefully read the sample question. Pause the video for approximately 5 minutes to consider and discuss the focus questions, and when you're finished, recommence the video. Well, the key concepts and skills that are targeted include interpreting trends in a scatter plot and understanding the term best in relation to describing a trend in a graph. The prerequisite skills and knowledge for this question include collecting and organising data and interpreting simple graphs. Working through each distractor in this question, the first one, well, this could be a reading, a comprehension, or a translation error. Students may have had difficulty understanding that the question is asking about the trend, or the context of the question may have confused them. The second one could have been a translation error. Students may have incorrectly assumed that achieving scores in the range 80 to 150 is close enough to call about the same. Phoebe's scores were all different. A possible comprehension error. Students may have interpreted the data incorrectly. Phoebe's highest score was in Game 6. Well, again, a possible comprehension or translation error. They may have interpreted singular data, which does not indicate an overall trend as the question is asking. And of course, the last one is the correct answer. Pause the video and discuss. Describing trends and relationships in any graph can be a challenging task for many students if they have not developed an understanding of looking at the big data picture. As often, the focus of the learning is concerned with identifying the value of singular data points. Now, the key idea in this type of question is telling a summary story or statement with supporting evidence so it fits the fourth step, reading beyond the data. Now, a very simple but effective strategy to aid visualization is to use a thick highlighter and hand draw a line that fits the bulk of the data points, a line of best fit in a way. The line allows students to see the trend of the data, and it applies the tree before the forest adage, where often students cannot see the trend for the individual scores. What if statements could add valuable investigations, such as, what if the last 3 scores were not on the graph? How would you best describe what happens to Phoebe's batting scores now? Let's consider questions that cover all 4 steps. So, using this graph on eggs, let's investigate the types of questions, such as, identify the greatest number of eggs laid in a week. What do you notice about the hens when the greatest number of eggs were laid? What was the least number of eggs laid in a week? What do you notice about the hens when the least number of eggs were laid? Freehand draw a line through the data that best fits. Use a highlighter. Don't try and mark every dot. We are not trying to create a line of best fit either. Rather, we just want to highlight the data. Use prompts to encourage students to discuss the trend of the highlighted area they have marked on their graphs, such as, what do you notice about the number of eggs laid over the years? What is the best statement you could write to describe the number of eggs over the 9 years? What is a general statement you could make about my hens using the data? Now, the choice and variety of questions that the students are exposed to will determine their learning and understanding. Well, here is an example of a question targeting Year 6, Stage 3, interpreting information from a line graph. Only 47% of the candidature was successful in attempting a similar question. Why was it so difficult for our students? Carefully read the sample question. Pause the video to consider and discuss the focus questions, and when you're finished, recommence the video. The key concept and skills that the question is targeting is interpreting a line graph. The prerequisite skills and knowledge is the collection and organisation of data. Well, let's consider the errors in reasoning for this question, applying Newman's analysis. 3 kilos, a reading or comprehension error. Students may have selected the Joey's weight at birth. 3.5 kilograms, a transforming error. Students may have calculated the weight gain from 2 months to 8 months. 5 kilos, of course, is the correct answer. 7 kilos, a comprehension or transforming error. Students may have calculated Joey's weight gain for the first 12 weeks represented on the graph, or they may have just counted the dots. 8 kilograms, another reading or comprehension error. Students may have identified the weight at 8 months rather than the difference. Pause the video and discuss. So, to consider the teaching and learning, we need to analyse the question. Now, this question requires students to read specific data from the graph, then calculate the difference. So it fits into the reading between the data step, interpreting and comparing the information. Teachers often give their students a lot of opportunity to represent and read the data, but not always in a meaningful context. When interpreting graphs, it is imperative that students have ample opportunity to explain and justify their reasoning and receive feedback. Students should be working in pairs or small groups. Making comparisons in any graph can be a challenging task for many students if they have not developed an understanding of looking at the big data picture, as often the focus of the learning is concerned with identifying the value of singular data points. Taking the original graph and removing the units from the axes places the focus on descriptive data analysis rather than the individual data points. Now, this activity with discussion will promote synthesis of the information in a graph. Use prompt questions such as, how would you describe Scotty's weight gain? What do you think will happen to Scotty's weight as time goes on? What if the last data point was not on the graph? How could you describe Scotty's weight gain now? What do you think will happen to Scotty's weight in the future? Allow students time to discuss and clarify their answers with each other or in a small group. It is important that our students are exploring data to answer questions that they want to know the answer to, and they explore new questions that are raised by the data that they have collected. Now, an effective activity for your students is to ask them to find a graph which illustrates the data that they are interested in. Write an analysis of the data from their graph. Allow them to use the infographic as a prompt if they want. Share and discuss their findings. Students can then categorise their analysis points under the 3 headings. I am reading the data, I am reading between the data, and I am reading beyond the data. Students can then share their analysis with another student or small group. Now, this webinar has certainly made me reflect on my ways of teaching data. And as I stated in the beginning, we cannot begin to triage data representations in one short webinar, but we can reflect on the following. Just how good are the strategies we currently teach our students to unpack data? Or are our students simply mining graphs for information and meaning? Are we certain our students have the skills and knowledge to read the data, read between the data, and read beyond the data? And can we honestly say that we are hitting all 3 points? Is the time we give to the interpretation of graphs enough? Pause the video and discuss each of the questions with your team. And finally, did we hit the mark? Well, here's the success criteria for the webinar. Discuss them with your team. What can you employ in your classroom to support your students' learning? Thank you for joining me today.